Hello guys, welcome to Pepcoding, and now we are going to discuss the next problem, that is count all single child parent in a binary tree. Actually, this question is the extension of the last of our previous question which we have done. In the previous question, what we have done is we have written the list of all single child parent node. Okay, but in this question, what the difference is, we have to return the count. Okay, so what we have to return? We have to return the count of all the single child parent node. Okay, so let's go and understand this. What actually we have to do in this question. Okay, so see, in this question we have to return the count. That is, what are the single child parent node? This is the first single child parent node. This is the second single child parent node. This is the third single child parent node. Let me highlight this. So this is first single child parent node, second, third. Okay, so these are the single child parent node, and you guys have already know like what is single child parent node. So if you have not watched my previous video, so I will recommend you to please watch that video first, then you can easily understand this question. Okay, so in this question, what we have to do, we have to return the count of this, that is 3, 1, 2 and 3. Okay, in the last question, in the previous question, what we were doing, we were returning the list of this, like 60, 40 and 70. Okay, but in this question, what we have to do, we have to return the count of this. Okay, so like for solving this question, there are two approaches. Okay, the first approach is by using a global variable. Okay, and what is the second approach? The second approach is that we have to directly returning the count. Okay, returning the count of single child parent node. Okay, so first what we are going to do is we are going to solve this approach. Okay, so this is exactly similar to the similar to our previous code. Okay, the only change we have to do in this question is we have to just increment the value of count instead of adding in the list. Okay, so let's do this. So I'm going to code this, and for this I have to take one count, that is 0, and I'm going to code this very fast because I have already explained you in the previous video. Okay, so let me remove this. So now I have removed all the things. Now I'm going to code this. Okay, so what I have done is, if node is equal to null, ptr, or it is a leaf node. So first let me do the full screen. Now I'm going to code or node of left equal to null and node of right equal to null ptr. Okay, then in that case what we have to do, we have to return it. Okay, then again I have used the if node of left is equal to null ptr or node of right is equal to null ptr. Okay, so then in that case what we have to do, we have to increment the count, and then I'm going to use the two calls, that is for left as well as for right. Okay, so this we already know the flow of this code. Okay, so in my previous video I have deeply discussed this thing. Okay, this condition also, which is the main thing in this question. So let me do right. Okay, so let's run it now and check this, and it is running. Okay, so this we already know. So what is the second approach? That return? Okay, in the second approach, in this we are going to use the faith. Okay, faith of recursion. So how can we do this? So what I'm going to do is, this root node is going to ask the count of all the single child parent node to the left side. Okay, it will say to the left side that go and find the count of all single child parent node, and it is also going to ask to the right side also. Okay, so the right side will give the count and the left side will give the count of single child parent node. Okay, so what the root will do is it is going to return the addition of these count, like it is going to add these two count. Okay, so this is actually the faith call. What is the faith? Like the left is going to give the count of single child parent node, and right will give the count of right side for single child parent node. Okay, and what the root will do, root is going to add these two and going to return this. Okay, so let's see this. I'm going to change the code according to this. Okay, so for this we have to take int, and I'm going to remove this count. Now I'm going to change thing here. So there was answer, and I'm going to store the value of answer. Okay, so I have corrected the code. So now what I have to do is, first I'm going to comment this. Okay, so it is going to return 0 if any of this condition is true. That means if node is equal to null, or the node of left equal to null, and right is equal to null, that means leaf node. Then in that case what we have to do, we have to return the 0. Now I'm going to give the left's call. That is, I'm going to ask to the left side that I want the count of single child parent node. Okay, so I'm going to give the left call, that is left count. Okay, so left count. So I have taken the variable that is left count. Now I'm going to take one more variable, that is right count. Okay, so I have taken these two variables. Okay, then in the end what I'm going to do, I'm going to add these two values. So I have taken one more variable, that is answer. So left count plus right count, and I'm going to return the answer. Okay, so do you think like this code is 100% correct? No, actually this is not 100% correct. What is the reason? What is incorrect in this question is, see, I have taken the count to the left side. See, let me take one example. 20 is there, 30 is there, 40 is there, 50 is there. Okay, so what I have done is I have taken the count of to the left side. I have also taken the count to the right side, but we have not checked for myself, that is root node. Okay, so according to our this solution, what is going to what we are actually asking is, it is going to return 1, and this is going to return 1. But what is the answer? Answer is actually 2, because there are two single child parent node, that is this one and this one. Okay, because this root node is also a single child parent node. Okay, it is also having only one child, and sorry, not 30, it is actually 20 and 10. Okay, so how can we do this? So we can do this by checking ourselves also. Each and every time I'm going to check for myself also. So how can we do this? So this code was for checking the single child parent node. So this we have already seen in the last video. So I'm going to check for myself. That is, if node of left is equal to null, or node of right is equal to null. If any of this is null, that means what we have to do, we have to increment the answer. Now we have to increment the answer. So if you have seen my previous video, then you have already understand the meaning of this line. So why this is working? Because we have already checked this condition, and this is false. That's why we are in this position. Okay, so if this is false, that means the left and right both are not equal to null. That means if any one of them is equal to null, that means the second one is not equal to null. Suppose the left is null, so then it is 100% confirmed that right is not equal to null. Okay, that's why it is working. So we have already discussed in our previous video very deeply. Okay, we have also done the dry run for this. So now I think it is going to run. So let me run this and check it. So it is accepted. So let me dry run this. Okay, so let me take this snippet for this. So let me just reduce the number of lines so that it will be easy to dry run. Now let's take this code. Okay, so this is our code. So let me take this. Let me do this small. Now I think it is easy to understand. Okay, so now what I'm going to do is I'm going to create one stack, and then I'm going to understand. Okay, so first I am in root node. Okay, so going to 10. So first I'm going to check for myself is I'm a null or a leaf node. This means a leaf node. Okay, if I'm a leaf node, then what we have to return? We have to return 0. Then I'm going to check for the left side. Okay, then I reach there. Then again the same thing is going to happen. I'm going to check for myself. I'm a leaf node or a null. That is not true. So again I'm going to move towards the left side. Okay, so 20 of left. Then then the call of 90 is going to hit. Okay, so this is a leaf node. So what is going to happen is this is going to return 0. This is going to return 0. Okay, then what is going to happen? 90 will wipe out and our second call will hit. That is the right side, this one. Okay, so in this line it is written the left count is 0. Okay, the left count is 0, and now we have to run for the right. Now it is going to move to the right. That means 60 is going to push into the stack. Now is this a null? No, this is not a null. So now what we have to do? We have to move towards the left side. So again we have to move to the left side, that is 80. Okay, so this is leaf node. So what we have to return? We have to return 0. Okay, so then 80 is going to wipe out, and now what we have to do? We have to go for the second call, that is the right, and this is also 0. So this was 0 and this is actually also 0. Okay, because both we have used both the calls. Now we have to come here. So what is the answer? Here is also 0. Okay, so what is the answer? In this there is variable answer, and answer is the summation of these two. 0 is going to be answer. Then what we have to do? Then we have to check for myself also. Am I a single child parent node? Yes, that is true. That means because this condition is true, so this is true. So I'm going to increment the answer by 1, and then what we have to do? We have to return it. Okay, so I'm going to return it. I'm going to return it in 20 of right. Let me erase this first, and I'm going to return the answer. Okay, so I will return it from here. So 1 is going to return. Then 20 will also get wiped out because we have used all the calls. And yeah, one more thing, I have to do the sum, that is 1. Okay, and I have to check for myself also, but this is not a single child parent node, so I'm going to return 1 only. So 1 will be returned from here. Okay, so this faith is true. So this left part has given return the 1. That is true. Now I'm going to move the right side. Okay, so let me erase it, all the calls. Now our next call is going to hit, that is right call. Okay, so now I'm moving this side. So 40 will be pushed into the stack. Now 40 is going to check it. It is a null or a leaf node? No, it is not. So now I'm going to hit for the left call. So now I'm moving here. So 70 is going to push into the stack. So it is a leaf node or null? that is false. Now again I'm going to check for the left. So for the left there is null. Okay, so it is going to return 0 here. 0 is returned. Now I'm going to return for the right. Okay, so if we are going for the right, so 100 is going to return, but this is a leaf node, so we have to return 0 out of here. So the right count will be the 0. Okay, so for 70 we have to add the answer, that is answer is equal to 0, and now we have to check for myself also. Okay, so it has used all the both calls and it is going to check for himself also. Okay, but this is a leaf node, this is a single child parent node, so what we have to do, we have to increment the answer. Okay, then we have to return it, then again it will return 1, then again it is going to check for this, so answer is equal to 1, and it is going to check for himself also, so it is going to return the it is going to increment the answer by 1, that is 2, and it will return this 2 here, and then again it is going to check for himself, but this is not a single child parent node, so it is going to return 3. So like this our code is flowing. Okay, so this is the flow of our code. So now let's submit this and check for all the test cases. So all the test cases are running fine. So thank you guys for watching this video, and we'll meet you in the next video.